Hello and welcome back to another episode of the Physiology of Endurance Running podcast. So today we're going to talk about heat. Heat has been increasingly more, I think increasingly more athletes are using heat, and so you see it on social media, people jumping in hot baths and this notion that heat is a poor man's altitude. We're going to dig into that a bit today. But first, just like to give a shout out to our sponsors, SAW sponsoring our podcast for the next couple of months. And if you haven't come across them, just really, really nice running apparel, great vests, great shorts. We gave it a bit of a review in my last episode of our Road to Valencia series. Both of us have tried them out. We're going to Owain's got some grand plans to stress test his a bit further. How many gels can you get into the marathon shorts? That's the question. We're going to put that to the test. But yeah, we'll save that for another day. Owain, how are you doing? Are you ready to talk about heat?
Yeah, ready to talk about it. We've both spent enough time being research guinea pigs in baths. So we're going to talk about that and why we're doing that. Why we're making ourselves very uncomfortable. We're recording this a couple of hours ago. I had a participant in the bath as part of my research, suffering a bit. I don't think it was too bad for them, but yeah, we're going to talk about why you might want to put yourself through that. Yeah, should we start? So as you said, and as I think it's quite a popular it's quite a common thing with runners, isn't it? You know, heat is like the poor man's altitude, and you know, people tend to find anecdotally that you run really well in the northern hemisphere in that sort of window, late August into September, where you've been training through the summer, and then suddenly it gets cooler and it just feels like you feel like you're, you know, another level of an athlete, right? Like you're feeling way better, and there's some physiology behind that, which we're going to go through. But I think picking apart that sort of that saying, poor man's altitude, we thought it's actually best to talk about why you would go to altitude first, because without that probably you're not going to be getting in a bath if there was no reason to go to altitude. You know, it's an alternative form of chasing some physiological benefit. So altitude, in terms of physiology, like we've said, we're going to do a whole other episode on altitude and maybe some of the history of it. But I think in terms of the physiology, you sort of go back to, I've got it here, 1997. There was a absolutely seminal physiology piece of work or paper published by Ben Levine and I've forgotten his first name, but Stray Gunderson, which effectively, had a couple of groups: live high, train low, live high, train high, live low, train low. So high being high altitude, low being low altitude. And they basically found the live high, train high and live high, train low groups had an increase in VO2 max. And that paper's cited basically in every bit of work now on altitude. There was a big paper last year, or maybe this year, 100 seminal physiology papers, and that's one of them for altitude. It's anyone mentioning altitude will cite that paper, and that sort of set this going. I mean, anecdotally as well, people would have been going to altitude for their training. You know, you've had events like you had the Olympics in Mexico, which would have set some people sort of thinking about altitude. But yeah, this is sort of the seminal point in physiology where altitude as a stimulus sort of comes about, and then from there there's then been, you know, loads more work on altitude. And really the basic reason why you'd go to altitude is to increase your hemoglobin mass. Hemoglobin's a protein that sits on your red blood cell, and it's what oxygen binds to. So if you have more hemoglobin, you can carry more oxygen to your working muscles, basically. There's some other sort of thoughts about why you'd go to altitude, right? Like, I think there's some thoughts about increasing maybe the cellular function as well, because if they're in a hypoxic state, then that might increase their function. But I don't think it's sort of fully fleshed out, really. That side of it.
I think the established reason of why you would go to altitude is to get those hematological adaptations. So, like you said, increase your hemoglobin mass. And I think we should dig into hemoglobin mass versus like hematocrit or hemoglobin concentration as well, because That's really important. What we mean by hemoglobin mass is in grams, how many red blood cells are going around your body, going around your blood, right? And that's what seems to be important for performance, because if you you could have a your hematocrit, for example, which is the ratio of red blood cells relative to all the other plasma in your blood, right? That's very influenced by your hydration levels, how much blood volume you've got. So you could have two athletes with very similar hematocrits or hemoglobin concentrations, like the concentration of red blood cells in your blood. But if one athlete has got more blood than the other, then their oxygen carrying capacity is much higher. And one of the adaptations you get from training is that you just have more blood. So you have more blood, but additionally, if you go to altitude, you have more blood, but also a higher proportion of that is going to be red blood cells too. So that's, in terms of what correlates with performance, hematocrit, hemoglobin concentration, not too much of an association, but actually hemoglobin mass seems to be the key variable, the total amount of red blood cells that's going to drive your oxygen carrying capacity of your blood, and then in turn your VO2 max.
And yeah, like we said, I think we'll do a full episode on altitude, sort of pick apart some of the physiology underpinning it. But there's there's potential advantages of altitude, like we said, increasing your hemoglobin mass. But there's quite a lot of drawbacks of altitude, which aren't talked, or maybe are talked about a bit. Some of them are quite obvious, others are less so. From a physiology perspective, the research in altitude is really hard to do. The sort of gold standard of research is double-blinded trial where the researchers and the subjects don't know what condition or what pill or what they're getting. And that's really, really difficult to do with altitude, because when you're up a mountain versus living in Cardiff. There has been, there might have been a few more. There's one very good blinded trial where the athletes were in, I think it's called a nitrogen house, where they can change the percentage of nitrogen. And I think even then, I feel like anecdotally I'd heard that the athletes knew when they were, at altitude. But in that trial where the participants were actually blinded to being at altitude, some of them actually had a decrease in hemoglobin mass. So you're looking at that and you're like, okay, so when you've actually done, sort of the gold standard research, it doesn't actually work for some people. And this is like, they in the results, they show the individual results. So yeah, some people have an increase in hemoglobin mass and some people have a decrease, which is sort of pointing at one of the drawbacks beyond the research, which is the dose for an individual seems to greatly vary. So some people can get away with going to like 2,000 meters and going to Font Romeu or St. Moritz. I'm trying to think of other places. Flagstaff, I think, is about there. Boulder's about there. Some places are even lower. Like the Australians, when they go to the place has slipped my mind, but that's even lower. That's less than 2,000 meters. Yeah. For some people, that's fine though. But for other people, they might need to go to like 3,500 meters, which then brings in another drawback of how are you going to train? Like I don't think there's anywhere in Europe that's that high. You're going really, really high up, and there's no facilities at that point.
That's a drawback. Is actually the higher you go, the harder it is to actually run at race specific speeds. You can get the relative intensity, like you can get up to VO2 max. You can get your heart rate as high as you like and produce loads of lactate, but mechanically you're going to be at much slower speeds. You've then got the recovery cost as well, because I don't know if you've been to altitude, you'll know that sleep is really impaired, which is going to have a massive knock-on effect on your recovery and your ability just to do training. The terrain, like you said, the facilities aren't normally that great. Like that's the reason why there's only a few places. Everyone either goes to Font Romeu, St. Moritz, Boulder, Flagstaff, Iten, or Ethiopia. The reason is because there's not many places where there's good running at a high altitude with track access and just trails that are runnable. You could go up to 3,000 meters in Europe, Like there's plenty of mountains that high, but you wouldn't be able to run up there.
Yeah, you'd be spending all your day driving down to a track, wouldn't you? Yeah, which isn't the best. I mean, like I remember seeing pictures of, I think it was Font in like April, and they were like clearing snow off the track.
Yeah.
Yeah, so it's a consideration, and yeah, and like we said, like you could pay a lot of money to go to Font or St. Moritz, and then it turns out that you're someone where the dose you need is actually at 3,000 meters, not at 2,000 meters. And yeah, you've spent a lot of money because it costs a lot of money to go to, especially in Europe, to go to the Alps. And you know, you're potentially not working whilst you're there. Yeah, so
I guess the other drawback is if you are finding that you're actually struggling to tolerate the altitude, then you've got to fly home or drive down the mountain and find somewhere to stay down the mountain. It's not, you can't just turn off you can't turn off the stimulus like instantly. So that's another like downside of altitude. And I think it's just anecdotally as well. You see people come out of an altitude camp, and half of them do come out great, and half of them come out not so great. And it's hard to know who's going to respond, who's not. Is it the altitude? Is it the fact they've just overtrained a bit? There's so many factors, but it's a bit of a lucky dip who's going to respond, I think.
So you have these drawbacks to altitude, and you know, then also just even without all of the drawbacks, just from a practical sense, like it would be impossible for you, Dan, to go to altitude. Like you have a family and a job based in Cardiff, like so you can't do that. Yeah.
For 99% of the people, it's probably impossible. I've never been to altitude for a training camp. I'd love to go for a training camp because I love the mountains. I've been to the mountains plenty of times, but not for long enough to get the adaptations you need, or high enough probably like for the adaptations either. But yeah, if I could go away for 6 weeks and I'd love to go to Iten and Kenya and or St. Moritz or any of these places, to be honest. But that's not practical, feasible for, like I said, for most of us.
Yeah. So yeah, for most of the people listening, you're not able to go to altitude apart from, you know, like a brief trip. So then if we're thinking like, okay, how do we increase hemoglobin mass? And maybe we should have said as well, when we're talking about hemoglobin mass, there's a quite clear correlation between increasing hemoglobin mass and VO2 max. And that doesn't necessarily directly correlate to performance improvement, but from a physiological perspective, increasing your VO2 max is probably going to be beneficial. And from a research perspective, it's easier to measure VO2 max and get someone to race, isn't it? It's a lot tighter controlled.
There's a pretty much one-to-one relationship, like you said, between hemoglobin mass and VO2 max. So if you improve your hemoglobin mass if you increase your hemoglobin mass by 1%, your VO2 max is probably going to increase by about 1%. And for a lot of people, changing your VO2 max is quite difficult. Like it depends on your training age, your training history, what training you've been doing, but most of the adaptations you get that are going to improve your VO2 max through training are probably more to do with the structure of the heart, stretching your heart out so you've got a bigger cardiac output, because VO2 max, we've talked about it before, is primarily limited by getting the oxygen to the muscles. So it's a delivery limitation. It's not how much oxygen can your muscles use. If you provide more oxygen to your muscles, they'll use it. If you put someone on 100% oxygen, do a VO2 max test on them, their VO2 max will go up because there's more oxygen around. Training tends to increase the capacity of your heart, but it doesn't actually do that much. The hemoglobin mass, it's going to do a little bit, but this is where like interventions like altitude or heat, as we're going to talk about, can make quite a big difference.
So altitude's off the table. So then let's look at another stimulus that might increase hemoglobin mass. Do you want
to talk about tents?
I guess you could do altitude tents. There's I will say I'm not entirely sure where like the evidence sits, but I don't think it's particularly promising in terms of altitude exposure where you're doing more normobarics, so normal pressure reduction in oxygen. I've seen people like sort of, I guess you'd call it like microdose it as well, where you do, you know, like 5 minutes exposure every hour, or
Yeah, that's not going to be
short.
Yeah,
But
I think
it's not a big
again,
enough stimulus,
I'm
is it?
not clued up on the literature either, but my understanding is if you really want to get any sort of dose, you need to be in there 12 hours a day minimum to really get the exposure. And maybe you can accommodate, you can adjust a little bit by ramping up the actual altitude that you're, you know, the simulated altitude that you're at. So instead of being at 1800 meters like you're in, like in Font, maybe you go up to 3000 meters, but then you've got negative impacts there on sleep and also just for more practical things like an altitude generator is noisy. You get hot if you share a bed with somebody. That's really impractical. I don't think it's a fun experience. So again, not there's a lot of questions here about really is the effectiveness of it. And is there an effect? Can you get a big enough dose, and all the other just practical limitations around altitude tents as well?
So we're not going to go to altitude. It's not practical. It's too expensive. So yeah, what's another way to increase our hemoglobin mass? Because we've probably maxed out the capacity to increase your hemoglobin mass through exercise. And yeah, this is where heat comes in. There's some quite nice sort of work looking at heat in terms of just how it affects your physiology, like as a general physiology, and in terms of time courses of adaptions. There's a really, really nice paper by Perriard et al. From 2015, and that was looking at it from a perspective of, you know, things like World Cups in the desert. Fortunately, not too many, or some running races are in the desert. But yeah, like if you're playing a football World Cup in the desert, you want to be acclimatized to heat. And yeah, this was looking at the time course of adaptions, with a really nice figure that I think we'll stick in the show notes, a really nice like graph showing them. But we sort of know over time, once you're exposed to heat, if you're exercising in the heat, your heart rate will be higher initially, but then it'll actually drop down after sort of, I think, 7 to 14 sort of days as the time course. And I guess if you sort of start to pick apart why that might be the case, we're then coming back to using it as a stimulus. And yeah, this would be, I guess, if we start talking about different types of heat exposure, and I think it's worth separating them. So you can separate them into, I think, 2 categories. So active heat exposure and passive heat exposure. Active heat exposure would be where you're doing your exercise in the heat, and then passive would be where you're not doing exercise. Basically, like that's quite, I guess, black and white definitions of the differences. But yeah, so
you're using your heat instead of using your own, instead of exercising a hot environment or using your own body heat to heat you up, you're more having more passive heat, like jumping in a hot tub, going in a sauna, like that sort of thing, isn't it?
Yeah. And regarding active, there's again another sort of really nice big piece of work by another sort of big research group around altitude and heat. So this is by Ronstad et al., who's pretty prolific in sports science. I think he came up in our strength and conditioning.
He comes up everywhere. He's done stuff on periodization, on optimizing interval training to increase VO2 max. Yeah, he gets everywhere. Yeah.
And in this study, they had 3 groups of, I think they classed them as elite cyclists, but I think they were like junior under 23 cyclists. One group was a control, and then one group was doing their exercise in a heat chamber, and one group was doing their exercise in a heat suit. I'd say it's worth Googling a heat suit. It's pretty funny what they look like. But yeah, it's basically just a sort of full body suit that then pumps hot water around it to heat up your body, basically. And they did 5 weeks of training, is 5 times a week in these different conditions. And the heat chamber and the heat suit both had increases in hemoglobin mass. The heat suit was a bit better. They both had these increases in hemoglobin mass, exposing these athletes to heat during exercise, which maybe sort of, underpins what we were talking about at the start, where in August and September when you're running, you feel really good because you've been doing this sort of, I don't want to say by accident, but by necessity. You've been exercising during the summer. You've been having a form of heat exposure, and your hemoglobin mass has increased. And then you've got, there's also, thermoregulatory reasons why you feel really good in late August, September, but chances are you're probably also going to have a high
psychological as well, because the level of heat, we're going to talk about it a bit more detail now, but the level of heat exposure is probably much greater than you'd get even in the peak summer doing your normal training. You're getting your core body temperature pretty elevated, still within like safe limits. You need to be careful with heat because it can be really dangerous, but yeah, certainly it's more than just going for a run on a hot day. I'd say that's what it feels like to me when I've gone through the protocol.
You do have to be quite like rigorous, don't you, and like keeping at it. And I guess if you're just doing it naturally, like you can, in the UK you can encounter, in July 3 or 4 weeks of not very nice weather, and actually then the benefits sort of gone. But yeah, in these sort of more controlled trials, exercising in the heat had an increase in hemoglobin mass, again improving performance. There is some, I guess, drawbacks to active heat exposure. Anyone that's ever exercised in a heat chamber or really, really hot conditions, it's pretty horrible. We were saying it's horrible both physiologically and mentally. So if you're saying, okay, I want to go and do my easy run, and your easy run is normally at 5-minute Ks in sort of a temperate environment, it's probably going to be 6-minute Ks. And the same with your intervals, like they're going to be a lot slower. So you're going to lose the quality of training if you're training in a really hot environment. But also, just it's really mentally challenging. Like when you're hot, you're just thinking about being hot. Where you can go for an easy run, especially this time of year, and it's quite nice. You get to see the environment, and it's pretty nice weather conditions to exercise in. If you're doing it in 30 degrees, it's mentally not very nice. You're watching the clock the entire time.
Especially because you're probably going to be on a treadmill, aren't you? With to get that heat exposure this time of year with lots of layers on. And psychologically that's not fun. And I think it's what we talked about a bit about this on the last Road to Valencia podcast, didn't we? But trying to do it ends up like if you try to do it on an easy day, we end up having to actually run a bit harder to get the heat up, to get the core body temperature up, or you need to wear so many layers, but regardless either way you're going to get a big drift in heart rate compared to what we'd normally do for the pace, and the cost is just higher. And I think we were talking about you've got to make a choice about, is this going to be, where do you want to go? Is this going to be a heat training session, in which case you need to push your intensity a bit, or just know that this is going to cost you more, or is it a recovery day where you just want to go easy, because you can't really do both very effectively, I don't think.
And like we said, just really mentally challenging as well. Like personally, if you said to me I needed to do most of my runs in a heat chamber, like I know that I would just hate it the entire time, and that's not really sustainable to long-term training, is it? Like if you're absolutely dreading every run and it's horrible for 60 minutes, your training quality is going to go down, and sort of quality of life is also going to go down. Which is quite a big drawback, I guess. Also, it's not particularly easy to do. You occasionally see pictures of people's really like dodgy looking home heat chambers, where they've got like space heaters and stuff pointed at a bike or a treadmill, which is probably a massive electric bill.
I think it's easier to do cycling than running. I think you just naturally build up more heat because you haven't got any movement of your body really, like minimal. Like you can get on a turbo. It doesn't actually have to be that hot for you to really get up the core body temperature off. Not many fans on you. It's easier to wear layers cycling, I think. But yeah, running is definitely more difficult. You go to, I mean, you can go to a gym with all your layers on and get loads of strange looks, can't you? And yeah, I mean, I remember stories of Callum Hawkins preparing for Doha, because like there was the world champs in Doha, wasn't there? And that was all the track events. They had an air conditioned track, didn't they? Like they had cold air blasting out onto the infield. But the marathon was obviously going to be hot, and he did all his heat training in his shed with loads of heaters in there, but because it was going to be humid as well, I think they were trying to practice with the humidity. So they had like open kettles and stuff like that, just like boiling water away to get the humidity up. And I mean, that would be, I mean, he came fourth that year, so like it obviously worked, but psychologically that would be pretty horrendous.
I think that's a nice segue if we actually go to like event specific sort of heat exposure. So this would be where, you know, chances are you're probably not going to be running a marathon in Doha, but you know, you might be running something like Marathon de Sable. Sable? Is that how you say it?
Sable, yeah.
Yeah, or you know, another really hot marathon, or you know, any race, to be honest, that's hot in the summer. So you might want to use active heat exposure for event specific preparation. But I guess taking into account some of the drawbacks that we've just said, you probably want to be quite like careful about how you do it. I guess you like we said, you've got this balance that we're not really sure on the answer of like, do you do it on your recovery days, but you make your recovery days harder, or do you do it on your, you know, quality days when you're doing a session, but then the session quality is reduced? I don't think there's a right answer. But
I think it's clear, just to be really clear about why you're using heat. Are you like we're breaking it into, are you after those hematological adaptations, increasing your hemoglobin mass, increasing your VO2 max, or are you preparing for conditions in a race where it's going to be really hot? I think on your question just there, like if you're preparing for a race in a hot environment, right? I think for me, I'd go, well, if it's a key specific session where you want to be where, you know, you can have some intensity in there, but let's say it's a marathon, you're doing stuff at marathon race pace, then I'd go, yeah, let's do that in the heat, because it's the specific, you want to get used to also just the feeling of running at that intensity in the heat, get you dialing in the paces. What paces could you sustain when it's 30 degrees versus 10 degrees? And then you can use your easy days to recover. But I think it's I think you'd probably use a combination of passive stuff as well, I think, to try and get used to it. But so that's, I guess, do you think do you think we don't want to go too much into the getting ready for a hot race? I think that's a different topic, really.
I think that was where I was going to go to. That actually, you'll see some people like doing, you know, baths or like active heat exposure, and they're saying they're preparing for a specific event, but I think where it's a growing field is actually, like we said, the hematological benefits. I think we just wanted to touch on it, to be honest, knowing that we'll probably get some questions if we didn't. But like you sort of alluded to, a mix of active and passive might be best. And if we talk about passive, as we sort of mentioned at the start, that's things where you're not exercising, basically. So the main ones are going to be like baths and saunas. You could probably also go sit in a heat chamber. I guess it'd sort of be a sauna anyway, but these are where you're not exercising whilst you're doing the heat exposure. You are, you know, in the case of a bath, literally just sitting in the bath. Where these have benefits are that you're not trying to exercise during them. So you're not trying to find the balance that we've just said we don't know the answer to, of do you do your easy days or your hard days doing these heat exposures. And then they can run concurrently to your training. And I think in our experience of having done them, they can be sort of fitted around your training and sort of, I guess, maybe individualized quite nicely. Where we've both done heat exposure, I tend to be I'm almost always a run once a day kind of person. So then heat exposure works quite nicely. Passive heat exposure works quite nicely in tandem with that. Whereas Dan is a generally run twice a day type person, but passive heat exposure could fit in on the days where you don't run twice a day, and active could be maybe the second run of the day. You do some heat exposure. So bringing in passive heat exposure definitely like opens up some, I think, flexibility and more ways of bringing in the heat exposure. I think if we just quickly talk about some of the physiology, I don't want to go into too much detail because I think it's almost a follow-up. I have a follow-up podcast in mind with a specific guest about this.
Yeah. Will he say yes, though?
Yeah. The sort of possible methods at work. So why you end up after a few weeks of heat exposure with an increase in hemoglobin mass, or potentially an increase in hemoglobin mass. And there's sort of a couple of things that might be happening. And we've sort of seen this where we've done heat exposure, but generally in the first week of doing heat exposure, you're going to have an increase in plasma volume. So your hematocrit, so like Dan said, the ratio of red blood cells to other products in the blood will drop a little bit. So you'll get more plasma volume, and where your hematocrit, is going to sit somewhere between 38 and 45 if you're not taking loads of EPO like 90s cyclists. Yeah. It's going to sit somewhere in that range. It's going to drop a couple of percent because you're going to expand your plasma volume. That's sort of a really quick change.
You just have that's a really quick adaptation, like you said. Sorry, I'm cutting in there, but no. You end up with more bloods, but mostly just the plasma, and by plasma it's the liquid portion of the blood, so not the red blood cells, not the white blood cells. It's pretty much the water and soluble things within that, so glucose, proteins, whatever. But that's a really obvious adaptation to the heat, in that if you're going to sweat loads, you want more blood, so you're not going to become severely dehydrated. It allows you to have a greater sweat capacity without it obviously dehydrating you massively. But those things, because you're not producing new proteins, you're not having to build structures. Like it's not like rebuilding and remodeling a heart, which is going to obviously take a long time. Your blood volume is really changeable. So if you're going to do the opposite and put someone on bed rest and not exercise them for 2 or 3 days, you could have a 10% drop or more in blood volume. But within 2 or 3 days, be back to normal if you go back to doing normal activity and training.
So you get this increase in plasma volume, and then this is sensed by the kidneys. The kidneys regulate blood volume, or a part of the sort of process of regulating blood volume. And specifically, there's a area of the kidneys, don't know if I have it written down actually, but it's sort of referred to as the crit meter. So hematocrit, got it here. No, I don't actually. But yeah, so the first week or two, you expand your plasma volume, and that drives hematocrit down. And then within your kidneys, the crit meter senses this sort of change in your hematocrit, and it wants to bring it back to the same level as it was before, because everyone will sort of sit at a different level, but within that sort of normal range mostly. If you're a lowlander, you're not living at altitude. But yeah, you'll sit within that sort of normal range, and so your kidneys will respond, and they'll say, okay, we need to increase the amount of red blood cells to get the hematocrit back to where we want it to sit, and that signals an increase in EPO. And then 2 to sort of 5 weeks later, you then start to see that increase in red blood cells. It takes, I think maybe also worth mentioning, like, you don't just inject EPO and get more blood. Erythropoiesis and like the creation of new red blood cells, it's always happening because you always have a turnover of red blood cells in your body. They're constantly dying and having to be replaced, but it's not like you just upregulate your EPO today and then by the weekend you'll have more blood. It takes a few weeks for that process to, from signaling EPO to a mature red blood cell takes a long time. So over that sort of 5-week period, you see an increase in plasma volume and then an increase in red blood cells to bring back hematocrit to the same level. And then at the end, you're left with an increase in total blood volume, an increase in red blood cell volume, and then within that, increase in hemoglobin mass is one of the theories.
Yeah, because I've also seen it suggested, but it's more acute than that, in that you get dehydrated
Yep.
during your hot bath.
Yep.
There's less blood flow to the kidneys, and then there's an increase in EPO because it's not getting it's not perfused as well, so they want to protect against that increased EPO response.
Yeah.
And then produce more red blood cells, increase oxygen delivery to the kidneys, and then you've rectified it. You're back to normesis.
So that was that's second sort of mechanism. To mention, and like you said, kidneys are really responsive to seeing a change in oxygen levels, and that's at altitude or hot water or heat exposure. Like Dan said, you jump in a bath, you'll sweat a lot, and you have a reduction in plasma volume, and blood is going to be sent to your periphery to cool you down, and your kidneys see that. And what the way I've sort of summarized it in a presentation I've done on this is that these sort of perturbations to your kidneys, if you do it every day, you're going to just upregulate the amount of EPO production, and then weeks later have an increase in blood cells and an increase in haemoglobin mass. That's sort of been looked at by a research group in the University of Oregon. They were looking at renal blood flow, so kidneys, or renal blood flow is blood flow to the kidneys. And they saw when you do a bath, there is a drop in renal blood flow. That could be another mechanism at play. There is one more, which is just it's a similar sort of thing, but you have a bath or go in the sauna, and then after your kidneys have a higher oxygen demand, which is sort of the same mechanism, but then also an increase demand for sodium, and again that sort of perturbates the kidneys, and increases EPO signaling. At the moment, and I think this is where maybe a follow-up podcast will go, it isn't quite clear which of these is at play. My research is looking a bit at this. We're looking at whether the sort of changes in plasma volume will impact the EPO response. So I've had people jumping in a bath for 45 minutes, and then I've been taking blood samples, and we're going to be looking at EPO. And we've also had a control group just to compare. But yeah, there's a few possible mechanisms at play. What they all require, though, is for you to be doing this regularly. The amount used in research is 5 times a week and about a 5-week period. There's sort of historical reasons why that sort of time frame gets used in research. Some of it is about like how long students are at university during term time. I know I've seen that for like why you have 12-week studies, is because that's how long a term is at university, for when you can get participants.
You can do it very well if you get the students in on day one of your study, and get them involved all the way to the last day of term. But I think that's the thing. But I think that's where it differs from getting ready for an event in the heat. Like I said, like blood volume goes up really, really quickly. Our sweat response changes very quickly. So if your aim is to prepare for a race that's happening in a hot environment, then you don't probably need 5 weeks, and you don't probably need to be doing it 5 times a week. But if you're after hematological adaptation, so increasing your red blood cell mass, increasing your VO2 max, then you probably want minimum 5 weeks and 5 days a week, really, looking at to be confident that you're going to get a response. And I guess that's one thing, is we've got facilities to measure that. If you're just doing it yourself, you're not going to know. So you probably want to be a bit on the safe side and give it 5 or 6 weeks rather than doing it for 3 or 4 weeks and hoping that's going to be enough. I don't know.
And I think in that regard as well, you want to be sure that you're getting the right amount of dose for each bath. I was trying to think of the right way to say it there. So part of this as well is that you do increase your core temperature, and that means having a fairly hot bath. The participant I had today jumped in the bath and it was 44 degrees, and it really whacks you. The first 15 minutes gets quite uncomfy. After that, depends on sort of the individual. Some people it just keeps getting more and more uncomfy for 45 minutes. Other people it sort of levels off a bit. But you have to really sort of hit yourself with quite a big heat stimulus.
Yeah, it's not fun. If you
No,
think, if
it's really
you've been
not fun.
following along up to this point and gone, oh, what, a bath 5 days a week? That sounds quite relaxing. They're not relaxing and not fun. It wants to be at least 40 degrees to enable you to get your core body temperature up. It should feel uncomfortable. You'll get used to it a bit over the course of 5 weeks, but it feels uncomfortable. And even like when I did it last year, even on the last week, I wanted to get out after 35 minutes. It's a bit like, the treadmill, like you're stuck there staring at nothing. Like you can distract yourself as much as you like, but you want to get out of that bath.
And you also, maybe again, some like practical advice that we've maybe found is you need to have some, or you will find some, like, I guess I want to say mitigation strategies, like, you might put a limb out of the bath after 15 minutes, or I guess the main thing is getting your core temperature up, so keeping your core in the bath. Some people need to just get a limb out straight away, whereas other people sit, arms and legs completely submerged. And then also, like I personally found like I needed to eat quite close to getting in the bath. If I didn't, I would have like, as big a sort of hypo as you can get from running, to the point where I'd like struggle to get out of the bath at the end. But you sort of find your own like ways of doing it. Which is what part of, test it and try it yourself. Maybe make sure someone's around the first few times you do it, because
100%. So I think too, I definitely like there's potential to be a bit risky. So like you want to really have a proper thermometer, make sure you're regulating the bath temperature. Don't accidentally get into a 50-degree bath, like you're going to cook yourself. Keep it like low 40s. And then definitely the first time you do it, first couple of times, first 3 or 4 times you're doing it, make sure there's someone else around, because if you get up too quickly, you're going to pass out. And even when you've got out, the first time I did it, I got out of the bath, felt I was like fine. Then my vision completely went. I didn't pass out, but I just couldn't. I was just seeing like stars and had to lie down on the floor for like 10 minutes. And I recovered and I was fine. And that was the only time it happened. Every other time I was fine, but that first time really like whacked me. You want to make sure you're hydrated before you go into the bath. I think that's another big one. And you can drink during the heat exposure, but don't drink like 3 liters of water. You probably don't want to like. I don't know what your thoughts on that.
Yeah, I think there's some thought that maybe actually like hydration levels can change the sort of EPO response acutely. So potentially, I realize this is risky saying, but the more dehydrated you are, potentially the more benefit you get. But that's to say, don't be so dehydrated you pass out in the bath, because that will have a massive drawback. I mean, when we did it, we had a massive drawback.
You drown.
You drown. That's definitely going to affect your marathon performance. We were having 500 mils of water. And I mean, for me personally, I would get out, and part of our protocol was we had to weigh ourselves. And as soon as I weighed myself, I was drinking another sort of 300-400 mils. Whereas I see other people in my study have really not drunk much, and I've had to say to them, like, you probably want to drink a bit more. Like they've barely touched their drink.
No, I was always drink the whole thing and then just pray for more. I'd drink it all in the first 15 minutes and then just sit there miserable for half an hour.
I think it's maybe worth saying, when we did this as part of research, it's fairly tightly controlled in terms of there's always a researcher sat there with you. You can jump out of the bath if you're really uncomfortable. And like the room we were in, although actually Dan, you were doing a lot at home, weren't you? But like the room we were in at university had like ice there on hand as well, so we could really quickly cool ourselves down. If you're doing it at home, I would say maybe like don't be doing it where you have a race in Valencia in 4 weeks. You're probably leaving it a bit too late to get any benefits without really like hitting it hard, and potentially being unsafe. It's maybe like we're talking about 5 weeks because that's how long the research goes, but actually you maybe want to be thinking about almost like double the amount of time, like count on 10 weeks, because chances are you're not going to be able to do this 5 times a week without like absolutely driving your partner insane. Or yeah.
Yeah, I mean, like we said about it, we spoke on the last podcast. Like my plan was to do this in my final 5 weeks into Valencia, and I had a bit of a cold, couldn't fit it in for like 3 or 4 days. Was struggling to find my time anyway. So actually, I've not started again because I felt like the time frame's gone, and I was also just struggling to fit it into my lifestyle anyway, around training and work and kids and all that. So it's definitely one where, for me, like if I was a professional runner, I'd be doing it all the time. Or at least having like continuous big exposures, block of 5 weeks, maybe a week off, another block of 5 or 6 weeks. When you got the time to do it, I'd be doing it. I think there's so much merit in it and enough research to suggest that it can make a difference. I guess one thing we should speak about is how much benefit is it going to give you? Like, what are you going to increase your VO2 max by 10%? Are you going to increase it by how does it compare to altitude?
I mean, I guess for passive, there's not any published literature yet. I mean, I don't know about, can we say, like, I mean, personally, my VO2 max went up a bit. I say a bit, like a decent amount, where I would want to do it again. Whereas like Dan, yours didn't as much. How much did yours go up when you did this?
My VO2 max.
Yeah, did it?
It went down.
Yeah, it went down. Yeah,
but I think there are a few caveats around that. I mean, without going into too much detail, like I tested like a week. I ended up having to do a VO2 max test like a week after Valencia, so that was probably a factor. But interestingly, I ran further in the VO2 max test. My VO2 max was just lower. So my blood parameters they did move in the right direction. I was getting an increase in haemoglobin mass. So I think actually that could just be a bit of an outlier there. But I think, I've heard like, 3 to 4% increase in haemoglobin mass is probably not, wouldn't be unsurprising, which is similar to what you'd expect going to altitude. You're not going to increase your hemoglobin mass by 10% by going to altitude. You're not going to get a 10% increase in VO2 max, but you might get a 3-4% increase in VO2 max, maybe a 5%. I don't know. You're not pretty, depends on how long you're there, how high you are, have you taken iron before you go, like all these things. But I think we're talking comparable to going to altitude.
Yeah. And I think it maybe also depends on your training sort of volume anyway. Like when you did the study, you were probably running like 4 or 5 hours more than me. So for me, it maybe actually bridged that gap where I know it's not running, and like this will not replace running. Like if you're injured before Valencia, don't think like jumping in the bath is going to like fix it, sort of thing. But like it added to my training, and I was sort of saying to people, like I was sort of taking it as like it adds, we're doing 45 minutes a day, 5 times a week. Like that's, almost 4 hours extra training a week, where my heart rate was getting up quite high. Like we wore heart rate straps for a couple of the baths, and it's like almost at the end, it's almost at what an easy run would be for me.
How high was your heart rate getting?
Like I saw like 130 a couple of times at the end.
No,
like
you?
Getting out of the buff. Yeah.
So I never broke 100. Like I never broke. I think I got into 95. But considering my resting's like in my 30s, I guess that's it's quite a big increase in heart rate. But it is a different response, isn't it?
Yeah, and I was running pretty much every time. I'd run in the morning, and then do the bath at some point afternoon into like early evening. Which I think worked really well for me. That like it's something I could actually do myself. Whereas you were having to fit it around a lot of stuff, and maybe also worth saying, like a couple of times you had a bath quite late at night, and then your sleep quality is affected. Like you go to bed really dehydrated.
Yeah,
and then you wake up.
I was quite routinely doing it at like 9 o'clock at night, so getting out at like 10 o'clock, and then you can't go to sleep straight away because you're sweating buckets, and you've got to, like you said, trying to actually rehydrate before going to bed. You'd wake up in the morning feeling pretty like you got a hangover. So it's definitely one that it's much more feasible than altitude, but it's still something that's not easy to fit in around a normal life, I guess. Depends on your situation. If you're working from home, you could do some emails whilst you're in the bath. You know, my head doesn't work very well when my cognition is definitely impaired a little bit when I'm 30 minutes deep into a hot bath. But yeah. I guess there's other advantages. Do you want to talk about other advantages compared to altitude? I guess we've alluded to them already, but you can I think people do respond to it pretty well. I don't think it does add up that much fatigue, does it? Versus like when you're at altitude, like you have those things around sleep, increased carbohydrate use, other things that make the training load just higher being at altitude, which you don't have with the heat. You can also turn the dose off, can't you? Like you can just if you were responding to it badly, then you just don't go in the bath. It's easy. Whereas if you're at altitude and you're really suffering, then like we said earlier, it's pretty hard to just like drive down the mountain and spend a couple of days down there. It's not the most easy thing to do. And I guess you could personalize it as well, and that you can, if someone needed the temperature to be a bit higher, you can increase that, just run the hot water for a bit longer, versus driving up the mountain is not so easy.
Like you said, you can control the dose, and like we keep talking about 5 times a week, 45 minutes, but if you did 3 times a week, and even like 3 times a week for half an hour, that's it might take a bit longer, but that's probably going to lead to a similar end result over a lot more weeks. And there is some evidence that once you if you do this sort of 5 times a week, if you then maintain it through 3 times a week, that seems to work. So you can play around with the dose, and like you said, if you're feeling really cooked one week, just do a few less baths. It's not going to completely unravel the whole idea of doing it and the physiology behind it. I think we sort of mentioned a couple of drawbacks as well, didn't we? Like, some people get really lightheaded. Like I found I was generally fine to get straight out. Other people I know, like you were saying, and a couple of other people we know, like were just having to basically lie down on cold tiles, like as soon as they got out. So figure out how it responds to you, or how you respond to the stimulus, I guess. And then also, I guess it's worth saying for maybe older listeners, like it's potentially a bit more risky as well. Post the sort of hypotension, so lower blood pressure that you get after hot water immersion, seems to impact older people a bit more. So it's maybe one way, definitely like have someone about, and maybe try 30 minutes rather than 45. And
you can build up to it, can't you? I think you can start off with, I think you got to keep the temperature, you want the temperature to be at least 40 degrees, but you can build the duration up over time until it's a bit more tolerable, I think. Especially if you've given yourself the time to do it. You're not like goal race in 5 weeks, and you just crack on with it. If you've got if you're more flexible, or you just want to try to give it a go, then you don't need to jump straight into a full-on protocol. I think was there anything else you wanted to say?
No, I think hopefully we've covered it in a nice sort of introduction, and like this is why people are doing it. Like hopefully people have a sort of nice understanding now of why you might want to, or why you're seeing people talking about getting in the bath or going to the sauna a lot more. Like I said, I'd be really keen to do a sort of further episode.
I think
some of the really specific physiology, and maybe some specific data as well would be good.
And I think also one thing we haven't talked about is actually, we've talked about heat versus altitude, but I think there's probably some good or evidence coming out where you can combine the two, not simultaneously, but for example, maintaining those hematological adaptations you get from altitude by doing some heat training afterwards. Or say you can't get out to altitude, you could get to altitude for 2 weeks. Well, that's probably not long enough to really get the full benefits of increasing your hemoglobin mass, but maybe you did 5 weeks of heat training and then went into altitude, then that's going to have an additive effect. So I think there's like potential there, and we can talk about that more in a later podcast and dig a bit more in. But it's quite an exciting area because there's lots of research coming out, and it's quite applied. Like it's a good established intervention which seems to make a difference to performance, which is actually not that common, really.
also not too expensive. Like I think I looked it up
Yeah.
for a presentation, and I reckon I feel like I saw like maybe £130 a year to your water bill. If I think that was 3 baths a week. So that's that's a pair of shoes, isn't it? Like
I guess, yeah,
that's
versus going to altitude where you could easily spend, if you're going to altitude for 4 or 5 weeks, depending where you go, that could be 10 grand, couldn't it?
yeah.
With flights and accommodation and, getting access to a track and all the other stuff. Yeah.
So nice cheap sort of intervention that's really controllable. I think there's a reason there's a massive area of growing research, but it's also maybe lagging behind some of the applied uses of it, which is fairly typical for sports science, isn't it? Like the research comes second generally.
Yeah.
Like if this didn't work, you wouldn't see Tour de France cyclists using it. Or elite runners. So I think that about does us for this episode, but we'll definitely do some more, I reckon.
Yeah, definitely. Cool. So thank you very much for listening. As always, send us any questions you've got. Let's give Soar another shout out, because we really do appreciate their support. Go check them out. Link in our bio. Honestly, those Soar vests, those Soar shorts, I'm a big fan of. I'm going to test them out again this week. Great. Thanks for listening. Speak to you again soon.